Okay, so continuing along in lesson 5.5. And I don't know if I really want to flip, but if you flip back to the front of the page, I guess I probably should for a moment. Let me be good here. Okay, the problem we did at the bottom, it was solving the ambiguous case. And I don't know if I really pointed out that word yesterday, but the ambiguous case, meaning when they give you side-side angle, so two sides followed by an angle, that there are different options that could work out depending on the numbers provided. Okay, we looked here at this one example, okay, where the side opposite the angle was longer than, angle A was acute. The side opposite A was the longer given side. One basic triangle, we did the math. Okay? Now, we're going to look on the back at some of these other options. And if you look at example 1, or example B, solve triangle ABC given that A is 6, B is 7, and angle A is 30. So notice the angle again is acute, yes? But this time, A is the smaller of the two provided sides. And if you go back to look over here, and I'm going to show you in a picture here in a moment, but if A is acute and the side A is the smaller of the side, two triangles are possible. Okay? All depends on how one side is drawn. And that's what I'm going to show you here. Now, you will notice it says figure 5.19, page 436. And if nothing else, that's because I struggle with drawing this. So I'm going to show it to you in the book first of what the options could be, and then we'll go through and find the two sets of answers. So, and I know most of you probably don't necessarily have your books. If you have your books, you can look on page 436. But we're going to look at the two different ways we could draw this triangle.
So when you say, like this question about is A is acute, is that just when like A is smaller than like B and C, or is it just
Angle A is acute, meaning angle A is less than 90.
How do you know that if we just know side A is 6? Oh wait.
Or provided angle A.
I didn't realize we had both A, side A, and angle A. Sorry.
You have to be provided at least one angle for law of sines to apply.
I didn't realize we had both. I was looking at 6 and I was like, okay, yeah, 6 is smaller than 7, but I'm like, why are you saying it like that?
Okay. So, are we there?
Yeah.
Okay, good. That's all right. We got to make sure everyone's on the same page here. Okay, so based on the fact that angle A is 30, in both of these triangles, they have angle A showing here, yes? Side A is 6, and side B is 7. The typical triangle that you and I would draw without any given direction would be a triangle like this, right? Okay, I mean, that's just typical triangle. That's what we would draw. The idea that could happen is that these particular set of numbers could also work where if you take this side 6 that was here, dotted line, can swing over and fall under here and make it a very small triangle. Okay, and what it comes down to is just the numbers make this work. Because that side A is smaller than the other given side, it makes it an option. Okay, hold on a second, Shelby. What did you just ask, Carly?
What is the dotted line in this option?
So, this dotted line over here?
Yeah.
I think it's just trying to show you where it's going to swing to here in a moment.
Is there,
Oh, or the fact that if you think of 6 here, this would also be 6 here. It's an isosceles triangle. Okay.
that's how it
Hold on a second. Shelby, what did you need or ask? Is what? Yes. Try refreshing your screen or something. What's the trick when the video is not showing on their end?
That even rejoin.
I don't know.
That's the only way I can do it.
Okay. Shelby, if that doesn't work, did that work, Shelby? Okay. I say, because that was my thought. The other thought in the classroom was leave and rejoin, which not the best option, but okay, you can see now. Okay, good. Sorry. Okay, so the idea here is we have two different triangles we need to find. So because of the way this is provided, we have two sets of answers to find in this case. Okay, we're going to start by finding the traditional triangle, which is what you guys would normally draw. I would normally draw, right? And then we will look at how this triangle relates and find it. Got it? So you've seen the picture, you have an idea of what we're working towards, and when I try and draw it, you have an idea of what it's supposed to look like, right? That's what I have to, because I'm still going to try and draw it, so I have something to point to, but, okay.
So could you technically draw both triangles that were just shown in that picture because they both add up for side A, B?
Yeah, that's the whole point, is that both these triangles exist.
Okay.
Okay, so right up here in the top half, I'm going to draw the initial triangle. And I'm going to hopefully draw the other triangle underneath it here in a little bit. So here's A. A is 30. Side A is 6. Side B is 7. That makes this B, C, and C. Okay. So, okay, law of sines. Think about it from yesterday.
We have A and A, and then we have side A, angle A, and we have
So we can find.
side B. So we can find angle B.
Okay. We know our A's, so we can use sine A over A. We know one of the B's, so then we're going to use sine B over B. Yes? Okay, do the math there. Sine of 30 degrees over 6 equals sine of B over 7. Yes? Okay. Are you talented enough that you can multiply and divide all in one step?
Yeah. Well, isn't it just 7 times sine 30?
7 times sine 30, and then we'll divide by 6. So I'm going to write that sine B is 7 times sine of 30 degrees divided by 6. Can you agree?
Yes.
I did 2 steps in one, right? I did my cross products, but then I also went ahead and divided the 6 over. I've got a lot to fit in a little room. That's what it comes down to. Okay. Turn on your brains from yesterday. Inverse.
So make it,
Yeah.
make it just B.
In order to do B, we're going to have to do sine inverse of 7 sine 30 degrees over 6. If you didn't try your calculator yesterday, today's a good day to try it instead. Second sine of 7 sine 30 divided by 6.
35.69.
You guys agree? Yep. I'm just going to go one decimal place. So
35.7.
35.7 for one decimal place. Got your calculators cooperating with you? And 35.7 degrees, and that is angle B.
Well, now we can just find angle C. It's got to equal up to 180.
So next step would be to find angle C, because
All triangles add up to 180.
all three angles in a triangle always add up to 180. Back to your middle school math days. So I'm going to put this way up top because, again, I'm trying to, got lots of stuff I want to put in here. So angle A plus angle B plus angle C is equal to 180 degrees. So that means, let's see, what was A? 30 plus 35.7 plus some angle C equals 180. What did you find angle C to be?
114.3.
114.3 degrees. Okay. And
Now we can find side C, because we have angle C.
yep, we just found angle C. So now we're ready to find side C.
We use side A.
I'm going to use my A's again, so I'm not using rounded values. So sine A over A is equal to sine C over C. Remember, I still have a second triangle to do, so I'm not all the way to the right of my page by far.
Oh.
Now, good news is we don't have to have a ton of room in part C. So if you need to run down to part C, you're fine. FYI, okay? So, let's see. Sine of A, sine of 30 degrees divided by 6 equals sine of 114.3 degrees divided by C. Cross products, C times sine of 30 is 6 times sine of 114.3. If I go ahead and divide, so C is going to be 6 sine 114.3 degrees divided by sine of 30 degrees. Do your math again. Six sine 114.3 divided by sine of 30. Does your answer match my answer? One decimal place I'm going to use 10.9. Okay. For the orange triangle I have drawn there, have I found all my answers? Okay, so for the orange, we have angle C, we have side C, and we have angle B, right? And they all go with that triangle right there. Now, I showed you in the book, so you could see the visual, right? Because, and what they showed is, let's see. I'm going to try, then draw the new triangle right below. So the idea here okay. If you use the idea that that is the same triangle from above, correct? Okay. Angle A is still angle A. Angle C is angle C. But the idea is that angle B is going to kind of flop under. Okay? And the idea is because this side was only 6 over here, it can be drawn over here as a side of 6. Is what can happen. So, and I never get it drawn exactly right, but the idea is what remains here should be an isosceles triangle. I can't draw it right to make it look right because this is side 6, this is side 6. Okay? And that is, I should have said A equals 6. So now we've got to do this small little green triangle.
This is the math not going to be the same. Obviously, the angle is going to be different, isn't it?
It's going to be partially the same.
Except for the one.
But, I mean, here's the idea. The original information is still the same, right?
Yeah.
But keep in mind, angle C just went from being a big angle up here to a tiny angle.
And then B as well, right?
Okay? Side C just went from being this whole length to this tiny length here. So note, my new angle B is right here. My new side C is right there. And so we have to find, now, okay, what was B up in our previous triangle? It was 35.7 degrees, correct? Now, again, this is where me drawing a better picture would help. I'm trying to claim that this is a side 6, right? And right here is a side 6. So my idea being that this is an isosceles triangle. Make sense? If this is an isosceles triangle, what? Yes, my dotted line and this 6 right here. So these two 6's form an isosceles triangle. If this angle opposite the 6 is 35.7, what else do I know? Right here is a 35.7. So, okay, so if this over here, I'm not looking at the new triangle yet. Does it help? I don't know if my thumb makes that worse or better there, but I'm not looking at this new triangle yet. I'm looking at the dotted line triangle. This over here is 35.7 because it was up above. Because this is 6 and this is 6, those angles have to be equal. So this is 35.7 and this is 35.7. This 35.7 is not inside my new triangle, but it's right outside my new triangle and will help me find my new angle B. You see it? Okay, so have I made my case? Okay, so because this is 35.7 right here, we know that this angle inside here, right, the new angle B, has to add to 35.7 and equal 180. Okay, so I'm going to go do the math. Let's find our new angle. And I'm going over here.
Did you say we were using C?
We will. We have to find everything again.
No.
Just hang with me. Oh, part C, you will use part of it, but we won't need nearly all of it. Okay. So the idea is to find the new angle B, we have to take 180 because it's a straight line, yes, and subtract the 35.7. What is 180 minus 35.7? So the new angle B is 144.3 degrees. Okay. Can you now find a new angle C?
You just add the angle and together, and then subtract.
Okay. So we found the new angle B. The new angle C is based off the fact that all three angles still have to equal 180, right? So angle A plus angle B plus angle C is 180. Angle A, back from the given, was 30. Angle B we just found is 144.3 plus this new angle C, which should be tiny, right?
Yeah.
It should be tiny. Look up there at the top. So you guys have done the math there? And what was the new angle C? 5.7. And last part.
Now we can find side C.
We need side C again.
We just did a sine A, sine.
We can still use sine A over A. The difference is we're using the new angle C. So we're still using sine A over A equals sine C over C. So the same way we found C last time, it's just we have a different angle. So it's still sine of 30 degrees over 6, but this time it's sine of 5.7 degrees over C. Do your cross products. C times sine of 30 degrees equals 6 sine of 5.7 degrees. And then I can divide over the sine of 30 degrees. And C should be small, yes? 1 point what? 2? That's what I have written down. Do I need to do that on my calculator? I just realized I didn't put... I haven't been doing the basic math, but 6 sine 5.7 divided by sine of 30. Whoops. Delete that. Try again. 6 sine 5.7. This is why you always watch what you type, because as soon as I hit enter, I noticed it said 3 and not 30. Okay. 1.2. Okay. The picture is definitely key to understanding that one. Okay, I think it helps if you can figure out how to draw that picture and see the connections there.
Is the C example similar?
Yes. C example is smaller. You don't have to have a ton of space here. Solve triangle ABC, given that A is 8, B is 15, and angle A is 100. I am going to draw a triangle. I am drawing a triangle that has an obtuse angle, right? Because A is 100 degrees. What else do we know? Side A is 8, and B is 15. Thoughts on this problem?
The bottom right is angle B.
It is.
If you want to finish right.
I wasn't going to necessarily finish filling in the labels. What do you notice about angle A and side A? What do you know about angle A? What do you know about angle A? It's 100 degrees, it's obtuse. So what is angle A going to be in comparison to B and C? The biggest one, yes? So angle A is the biggest angle because it's already obtuse, so that means my other two are going to have to be smaller. You see it, Shively?
Yeah, but does it matter if we put B on the left or if we put it on?
It doesn't matter. B could go in either location. I just threw it on there.
Just an idea,
Right.
Okay. We could have even drawn the triangle like we had before.
Yeah, I made sure to draw an obtuse angle. What's the catch here, though?
That's not possible, right?
Why is this not possible? If this is the biggest angle,
That's why it says quit or like.
you get an error on your calculator when you start trying to solve it.
I didn't
Okay.
do anything wrong.
Okay, so side A, if angle A is biggest, side A must be biggest.
Oh, okay.
They gave me side B is biggest. So this triangle is not possible.
That's why you said we were going to do.
That's why I said you don't really need a whole lot of room because,
I assume there had to be one that thrown in there.
well, and I've hinted all along that I was going to show you an example of two triangles. I was going to show you an example of no triangle. So I'm going to write no triangle possible. Explanation, the obtuse angle must have the longest side opposite of it. Obtuse angle must be opposite the longest side. And thus you didn't need a lot of space on this one. Honestly, did you have to draw the triangle? No. You didn't have to draw the triangle. All you really have to write here is no triangle possible, but I would think it would be helpful if you write an explanation in your notes for when you look back at this later, you're saying why. That's why. Got it? Has to do with the 100 and the 8. So, okay. Ready for example 3? And we'll see how timing goes, whether we get through both these examples or just one of them today. I will say you have examples 38 and 39 in homework match up with these two examples here. So, at least to an extent. So it would definitely be helpful, but there's always Monday, right? Okay. Forest Ranger, Chris Johnson, whoever, the Forest Ranger dude. At Ranger Station A, sights a fire in the direction 32 degrees east of north. Did you bring your map skills with you today? Ranger Rick Thorpe at Ranger Station B, 10 miles due east of A, sights the same fire on a line 48 degrees west of north. Find the distance from each ranger station to the fire. Okay. I don't know about you guys, but I'm going to argue that a picture is necessary to figure out what is going on here, right? Now, keep in mind, it's law of science, right? We're going to see a triangle. We're going to use law of science to solve it. That's what it comes down to. So, with that in mind. Oh, okay, first of all, you guys know your compass? North, east, south, west. I'm older than you guys. I say never eat shredded wheats.
I heard something about soggy waffles.
Yep, never eat soggy waffles is more this generation. Yep. Okay, you guys know your directions,
I find
right?
it so funny. Never eat soggy waffles.
Yep. As I said, I'm an older generation. I say never eat shredded wheats, but I don't even know if do they even sell shredded wheat still?
I'm sure I'll skip it.
So,
I saw fire trucks.
okay. So, we have Fire Station A. Okay? He sights a fire in the direction 32 degrees east of north. So, where is north traditionally on a piece of paper? So the idea here, that's just a dotted line to give you guys reference. North is usually up on the paper, right? So where is east of north? To the right. So the idea is, he sights a fire over here. Now,
So is it the bottom? You're saying you'd be.
No, it's like an aerial view.
Oh, okay.
Yeah,
You're looking
aerial
up on
view.
top.
yes, we're looking down.
Okay.
Here's Station A. Here's the fire.
Where's that?
We're in the drone.
Gotcha.
Okay?
That makes sense now.
Okay.
I was like, why would you be-
Okay. So he sights it 32 degrees east of north. So what angle? 32 degrees east of north. Here's north. 32 degrees east of that. So your 32 degrees is right in there. Okay. Now, the ranger at Fire Station B. First of all, he is 10 miles due east of A. So, here's Fire Station A. Where is due east on a map? To the right. So, Fire Station B guy is over here. Not Fire Station, Ranger Station. And that is a distance of 10 miles. And he sights the same fire on a line 48 degrees west of north. Well, again, for the visual, north is straight up on the paper, right? So where is west of north? To the left. So he sights the fire left and hits 48 degrees of north, left of north, so 48 degrees is the distance between, if he was looking straight north, and the distance west he is, or the direction west he is looking. Now, do we think we got everything that they're given? Their questions to us is to find the distance from each ranger station to the fire. So we want to know this distance and this distance, which technically are which letters? A and B, if you will. Correct? Okay. Yes?
So then can we find, we basically still need to find everything else though, right? To be able to figure out what side A and side B are.
In order to know side A and side B, you have to know angle A and angle B.
Yeah, that's what I was thinking. So since we have that 36 degrees on the outside and 48 on the outside, we are within inside this, it's basically going to be the right angle.
Okay, and that's exactly what you need to notice. And that's part of the reason I draw in the north, is that this is, north and east, north and west, they form right angles, don't they?
Yeah.
So if this is 32 degrees, what is inside the triangle at angle A? 58 degrees. Does that make sense? It's a right angle, yes? Over at angle B, 48 degrees was between north and the angle west. So in here is 42 degrees.
And then now we have angle C, and it's not two together, and then I'll take the 180.
And then all three angles in a triangle always add up to be 180. And so that does make angle C 80 degrees. And yes, you need to know angle C to make this happen. Okay. Drawing the picture is the hardest part of this problem. We're on the downhill. Okay, we're on the slide. Okay. How can I find either side A or side B?
We know the angle of C and the side of C.
Okay. Law of sines. We know we're going to have to use the C information, right? Sine C over C because we know angle C and side C. And whichever you want to start with. I'll start with A. My brain does work logically, alphabetically, so start with B if you want to be a rebel. So sine C over C equals sine A over A. So sine of 80 degrees. I didn't label it. What is side C? That's a 10, right? I labeled it as 10. I didn't label it as C, is what I'm saying. There. So sine 80 degrees over 10 divided by sine of 58 degrees over A. You guys got the math under control? Yes? Cross products, say 10 times sine of 58 degrees is equal to A times sine of 80. So you get A by itself. I'm going to divide by 80. Sine of 80, yes. You got your calculator going? Calculators probably aren't quite as important today because you got a feel for them yesterday at this point, but did you get what I got? So A is 8.6. 8.6 what? Miles. Be a good math student. It's a word problem. And what is this side A?
It's the distance between
Ranger.
Ranger B.
Ranger B.
Okay. I'm going to go with Ranger B. It's a distance from Ranger Station B to the fire, yes? So this is the distance from Station B to the fire. Ranger Rick Thorpe if you want, but
I wish there would be Ranger homes on one day.
okay, and you guys can find the other one, right? Sine of C over C. Again, I like to use given values, not rounded values. And this time we're doing sine of B over B. So again, it's sine of 80 degrees over 10. Huh? Surely. sine of 80 degrees over 10. And B, what is angle B?
42.
Sine of 42 degrees over B. Probably not quick enough, but go ahead and do your cross products. So 10 times sine of 42, end up dividing by sine of 80. And you're going to put it in the calculator. And this is a lovely blurred screen.
Look, you had to use the space bar too.
I didn't even hit the space bar. I just hit whatever. Okay, I said what I was writing. I figured you guys could figure most of that part out. Okay, did you guys do the math? B is 6.8. Again, it is miles, and that's going to be the distance from. Knew you guys were going to do that to me. I'm writing Station A to the fire, or Ranger Chris Johnson to the fire. Chris Ranger, sorry. Now, keep in mind, he could have moved. So, technically, it's just the distance from his station. There you go.
Now we're doing the math.
That being a loyal Forest Ranger that Chris Johnson is, he would have stayed on watch.
Okay.
Are you gonna finish the example 4? I don't really know what the first sentence means.
Okay.
How to interpret it.
So, example 4. Honestly, when you get to example 4 in homework, the nice part is if the picture is provided.
Oh, okay.
That is what makes life so beautiful, because the hardest part of example 4 is that this picture is harder to figure out than the last picture. The last picture was very doable, I feel like. This picture, yeah. A road slopes 10 degrees above the horizontal, and a vertical telephone pole stands beside the road. The angle of elevation of the sun is 62 degrees, and the pole casts a 14.5-foot shadow downhill along the road. Find the height of the telephone pole. Okay. I'm going to cheat now. Here's the picture in the book. Okay? Can you guys see that? This is a picture in the book. And so the idea, the road slopes 10 degrees above the horizontal. So the idea, the road right here has 10 degrees with the horizontal. The angle of elevation of the sun, and this telephone pole is vertical. The angle of elevation of the sun is 62 degrees. So where does the sun come from? The sky, okay, up above. I'm going for up is what I was looking for, but the sky, that works. Okay, so the idea here that you end up with is the angle of the sun coming down. It makes a 62-degree angle right there.
So we can find angle C.
Okay. This is page 438. Okay, this is page 438 in the book. And as I said, and when you get to, this matches up with example 39. Example 39 is about a flagpole instead of a telephone pole, but they provide the picture. So when you get to 39, you're not allowed to say, she didn't get all the way through this in class, I can't do this. Try it with the picture in the book, okay? Because there's a picture on 39. They have a lot of information already on the picture, which will make life better, right?
Do you want us to redraw it?
You don't have to redraw it now. Okay, so the pole casts a 14.5-foot shadow downhill along the road. Find the height of the telephone pole. So you are looking, the triangle you're looking at is right here, if I recall. Okay, you're using all that information. So we're at 10:12. I can't really do a whole lot with this one right now. What I'm going to say, 38 mimics the problem we just did. 39 mimics this problem. Give 39 actual effort before you say you're stuck. Okay? Because, as I said, if you look at 39, here's 39. They have the picture, right? Okay, they have the picture of the flagpole. They have a lot of numbers filled in here. So see what you can do with that, because I think they have almost everything filled in for you. The triangle you're looking at is this triangle off to the left. Okay? So it really should be a pretty doable problem once you look at the picture.
Those are the lines that
It is. Except the better part is there's even more labels on it. Okay, your homework, have you written it down? Page 439, 2 through 12 evens, 20, 22, 38, and 39. Should be everything you need. Got it?
I think the only problem for me would be the language. That's gonna be the language.
With any word problems. I get it. Okay, bring this done for Monday. Ready to go over questions. That means Monday we'll check it, do